Problem 1.7. Imagine it rained for a while over a mountain area, the watershed, and it accumulated 3 inches of rain everywhere. Not all that rain soaked into the ground. Some of the water that didn't soak in drained down into streams and rivers, runoff excess, and was measured to be 21,780 cubic feet. We want to estimate what percentage of the rain actually became runoff. To do this, we'll also consider the total size of the mountain area to be 4 acres. Find the runoff coefficient, which is a way of expressing the amount of runoff as a percentage. Now, to solve this problem, we're going to use the runoff coefficient equation, which is runoff equals C times the precipitation. C is the coefficient equation. Solving for that, we'll need to values for runoff and the precipitation. To do this, we'll have to solve for runoff and precipitation both in the same, having in the same units. Before I move further into the problem, I would like to explain how volume is represented as inches and cubic feet. So I have an image here on the right side of the screen, and we have a watershed here. And if we add some depth to this watershed, let's see, if water accumulated, let's say in this type of bucket, this will represent all of this, the volume, right? So when it's represented just as inches, that means the depth of it, inches. And when it's represented as a cubic feet, that is not only representing the depth, but also the area of the watershed. So I hope if you were confused with this, why the different units represented the same thing, I hope this helps a little bit. So let's get precipitation and rainfall excess into the same units. To do that, we'll have to convert acres into square feet. And we'll do that by using the conversion table that I put here up on the right. And so we want to convert 4 acres into feet. In 1 acre, we have 43,560 square feet. Acres cancel, and we'll get square feet. So we need to multiply 4 times 4360, and we'll get square feet. Now, let's get precipitation into cubic feet. To do that, we need to convert inches into feet first. So we'll have 3 inches. There are 12 inches in 1 foot. Inches cancel, and we'll get feet. We need to divide 3 by 12. So this is precipitation in feet, and since we need it in cubic feet, we need to multiply this times the area in square feet. And now we have it in cubic feet. And all we have to do now is plug in. I believe we have everything we need. Runoff coefficient equals to runoff in cubic feet. Oh, excuse me. Runoff divided by the precipitation in cubic feet, and we get 0.5, which in percentage will be 50%. So 50% of the water that precipitated is becoming runoff. It's exiting the watershed. Now let's move on to problem 1.9. It says, imagine a parking lot that acts like a giant shallow basin of 6 acres in size. It rained on the parking lot, and the total rainfall measured was 0.88 inches everywhere. So this is the depth. This is not considering the area of the of the of the area of the parking lot. Sorry. However, not all the rainwater soaked into the cracks or evaporated. Some of the water that didn't soak in, called depression storage, collected as puddles on the surface. Now, we want to estimate how much water actually became puddles, also called depression storage or initial abstraction, in inches and cubic feet, based on the following information. So we are giving total rainfall amount 0.88 inches, the rate at which the runoff excess flowed out of the parking lot through the only drain is 5 cubic feet per second for 1 hour. To solve this problem, we need to make some assumptions about other parts of the water cycle in the parking lot. This problem will help us understand the hydrologic cycle, and we'll use the hydrologic cycle equation, which states that the runoff or rainfall excess equals precipitation minus evaporation minus transpiration minus infiltration minus initial abstraction. So let's grab the values that we are giving, and we get area 6 acres, runoff 5 cubic feet per second, precipitation 0.88 inches. And I put zeros here and I'll explain why. During the precipitation, we can make the assumption that there is no evaporation. Also, while it's raining, we can make the same assumption that transpiration is zero or is negligible. And infiltration, since we have a parking lot, we can make the assumption that the water doesn't infiltrate through the asphalt. So we can make the assumptions that all these three values are negligible, so they can be stated as zeros. With those being zeros, and solving for the initial extraction, which represents the puddles, we get only initial extraction equals precipitation minus uh, rainfall excess. Now, rainfall excess and runoff, they are, and even I mixed in sometimes. However, they have one special difference. Runoff usually represents a rate, it's compared versus time, and rainfall excess is only a volume. So in this case, we are given 5 cubic feet per second for 1 hour. So we need to get how much water or the volume happened in that hour. For that, we need to multiply this rate times an hour. So we have to do, okay, let's use the right side of the screen. We're gonna do 5 cubic feet per second times there in 1 hour there are 3600 seconds. Seconds cancel and we get the volume of water that happened in that hour. This hour we don't, as part of the problem, we can just avoid it. We already know that it happened, the precipitation happened during 1 hour. So to do that, we need to multiply this rate, 5 cubic feet per second, times 3600. And this will be the volume. This will be the rainfall excess. This is the runoff rate, and this is the rainfall excess as a volume. Now, uh, if we are given the area in acres and we're working with feet and inches, I usually like to convert everything into either inches or feet, depending on what the problem asks. In this case, it asks for both units. So we have to convert acres into feet. As we did previously, we have to multiply 6, 6 times 43,560. And this will be in square feet. Sorry, let me do a line here. Now let's also convert the precipitation into feet. Uh, to do that, we have to do equals 0.88. So we have there are 12 inches, 1 foot, inches cancel. We need to divide that by 12. And this is feet now. To get this into cubic feet, now we need to multiply by the area. So it's times the area that we found here. And this is cubic feet. Okay, now we have the runoff in cubic feet and the precipitation in cubic feet. We have the precipitation in inches and we need the runoff in inches. So we need to divide the volume by the area and we get feet. Now multiply these feet, to convert these feet into inches, we do the number of the, and we got it in feet. In 1 foot, we got 12 inches. We cancel and we get inches. So we need to multiply by 12. And I always do this because I don't, if I do it in my mind, sometimes I get it wrong. So I just rather spend the time writing it down just to make sure I'm doing it. I get the right answer. Um, so let's convert runoff into inches. It's gonna be this feet multiplied by 12, and that will be our value in inches. Now, now we can apply these values into our equation. Initial extraction equals precipitation minus runoff. That's gonna be precipitation in inches minus runoff in inches. And the same thing, precipitation in cubic feet minus runoff in cubic feet. And let me double check. Eleven 66.40. Yep. And that's the right answer. Now let's move on to 1.10. 1.10 says, imagine a large area in the mountains that collect rainwater. This watershed is 20 acres big. It rained for a while, and the total rainfall measured everywhere was 3 inches. However, not all the rain is going to contribute to runoff. Here's why. There is a lake in this watershed that takes up 30% of the total area. Since the lake level is low, the rain falling on the lake won't contribute to runoff. Also, some of the rain will soak into the ground. This is infiltration. We estimate that 1 inch of rain will soak in across the entire watershed, excluding the lake. We want to find the volume of water that actually becomes runoff or rainfall excess. To do this, we'll consider the total rainfall amount, which is 3 inches, the area of the lake, 30% of the total watershed, and the amount of rain that soaks into the ground, 1 inch. I have these values already plugged in. The area we're giving is 20 acres. The initial extraction, we're going to consider 0, and I'll explain why. The precipitation is 3 inches. As I mentioned before, evaporation and transpiration during the precipitation, they are negligible. And infiltration, we are mentioning in this case that is 1 inch. Now, to solve this problem, we're going to use the hydrologic cycle equation again, and we start plugging values. Since initial extraction, evaporation, and transpiration are 0, we end up with rainfall excess equals precipitation minus infiltration. Now, we are given that the area is 20 acres, but 30% of it is a lake that doesn't contribute to the lake, to the runoff, sorry. So the actual area that contributes to runoff is gonna be 20 acres times 1 minus 0.3 or 0.7. Only 70% of it contributes to runoff, which is 14 acres. And we are explaining that since we're already taking the lake out of the watershed, we don't have to consider the lake as an initial abstraction or something similar like that. Now, with this new area, we need to convert it into a square feet. So, as we have done before, 14 acres times 1 acre, we got 43,560 square foot. Acres cancel, and we get a square feet. So we multiply this 14 times 43,560, and we get square foot. Um, Now we need to solve for precipitation. We got precipitation in inches and infiltration in inches, and we need to get it in cubic feet. So we need to convert these both into cubic feet. Let's convert inches to feet first. 3 inches, 12 inches in 1 foot. Zero. If we cancel the inches, we get feet. So divide 3 by 12. So this is going to be equal 3 divided by 12. This is feet. The same with the infiltration. Divided by 12. This is feet. Now, let's multiply this times the area to get the precipitation in cubic feet. Same with the infiltration. Cubic feet. Now we can solve for rainfall excess. And that's going to be equal to the precipitation in cubic feet minus the infiltration in cubic feet. And we get 101,640 cubic feet. And let me double check. And that's the right answer. Let's move on to the last problem of this section, 1.11. This problem is very similar to 1.9. Imagine a 12-acre parking lot. Rainfalls, rain falls over the entire parking lot, and we measure a total of 0.9 inches of rain everywhere. Not all the rainwater soaks into the cracks or evaporates right away. Some of the leftover water forms puddles on the surface, which we call depression storage. We want to estimate how the depth of these puddles, inches and cubic feet, based on the following information. Rainfall amount, zero point 0.9 inches. The rate or runoff flowed out of the parking lot is 10 cubic feet per second for 1 hour. So we use the hydrologic cycle equation again, and we start plugging our values. We're given that the area is 12 acres, rainfall excess, or in this case runoff because it's a rate compared to time, is 10 cubic feet per second. Precipitation is 0.9 inches. Evaporation is negligible during the precipitation, same as transpiration. And since it's a parking lot, we can consider that the infiltration is also 0. Now solving for the initial extraction to get the depth of the puddles in the parking lot, we have to solve precipitation minus rainfall excess. So let's convert this runoff into rainfall excess, and we are told that the precipitation lasts 1 hour. So we'll do as we did before, 10 cubic feet per second, 3,600 seconds, and we get the volume in an hour, right? So we have 10 times 3,600 seconds, and now we have rainfall excess. We are asked to solve for inches and cubic feet. So we'll need this, we need the area in feet. So we have to multiply equals, as we done before, 12 times 43,560. This is the square feet. Now we have the area and precipitation. Let's convert it into feet. So if we have inches, let's divide that by 12 to get feet. And we have precipitation in inches and feet. We need it in cubic feet now. So let's multiply this value by the area and we get cubic feet. Now we have precipitation in inches and cubic feet. We have runoff in cubic feet. Now we need it in inches. Equal, we're missing the inches. This divided by the area and we get feet. Now let's get feet, and now let's convert the feet into inches. So it's gonna be this value times 12. Okay, now we have precipitation and runoff both in inches and cubic feet. So now let's plug in. Initial abstraction equals to precipitation, and this is inches, precipitation in inches, is 0.9 minus runoff in inches. And now here, this is precipitation in cubic feet minus runoff in cubic feet. And these are the values. Let me double check. 3,204 cubic feet and 0.074 inches. So those are the correct answers. So these were the four problems for this section. I hope the solutions can help you understand better hydrologic cycle and how to solve for runoff when you have precipitation, how to solve for the runoff coefficient when you have the runoff and precipitation. Remember to do the right conversions and you'll be good to go.